do the part 2 video for other types of equations. And for the first part here, we're going to be looking at absolute value equations. The thing about absolute value equations is that we could have 3 different possible scenarios for solutions. And so if I have the absolute value of, I have right here, ax plus b equals c, right? So we're saying this value right here, the absolute value, meaning the positive distance from 0, equals c. If the c value here is less than 0, okay, in other words, it is negative, we would have no solution. So this is one possible scenario, and I hope this makes sense, because the definition of absolute value is the positive distance from 0. So how do we take anything and make it a positive distance from 0 and then have it be negative? Okay, so that's not possible. So if we have a c value here that is negative, well, it's no solution. Now, if we have a value that is positive, now I'm looking at the second one over here, or this third one rather. If my c value here is positive, that means it could be 2 solutions. Let's just think about this. If this, let's say this were a 2, okay, if c were 2, then inside this absolute value, it could be a positive 2, because the absolute value of 2 is 2, or it could also be a negative 2, once we've evaluated everything inside here. If it's negative 2, then the absolute value of negative 2 is a positive 2. So we could get 2 potential solutions if our c value right here is positive. Okay, so if it's negative, we saw there's no solution. If it's positive, we see that it has 2 solutions. If it happens to be 0, if the c value happens to be 0, then that means that inside of this quantity right here, inside of absolute value, would also be 0. And so it would just be one solution. We don't have a positive and negative 0. So one solution. So let's see a couple of examples solving some absolute value equations here and see if this can make sense. So for this first one, we have the absolute value of 6x plus 4 equals 8. Okay, so let's take a look at this right here. This 8 here is a positive value. C is greater than 0. This indicates that we have 2 solutions. So what we're going to do here is we're going to break this up into 2 equations, and we're saying that 6x plus 4 here, inside this absolute value, it could be equal to 8. But it could also be equal to negative 8. So let's just think about this, right? This value inside here could be positive 8, because the absolute value of 8 is 8, or everything inside the absolute value could be a negative 8, because when we take the absolute value of a negative number, that would be a positive, so it would be a positive 8. So let's go ahead and solve for x here. So I got, let's subtract 4. Okay, this is just a linear equation here, so we're just isolating x. Divide 6, x equals 2/3. Okay, let's subtract 4 on this second equation. So I have these 2 solutions. And how about, let's just check it to prove that it works. So I've got 6, the absolute value of 6 times 2/3, so I'm just substituting x in here, plus 4 is equal to 8. Okay, so 3 goes into 6 2 times. 2 times 2 is 4. 4 plus 4 is 8. I get absolute value of 8 equals 8, and the absolute value of 8 is 8. So that worked. Let's try this one. We have absolute value of 6 times negative 2 plus 4 equals 8. 6 times negative 2 is negative 12 plus 4. Negative 12 plus 4 is negative 8. the absolute value of -8 is 8. Okay, so that worked. All right, so two solutions, and those solutions were 2/3 and -2. Okay, B. Absolute value 3x plus 4 equals -9. Well, this -9 means that its C is less than 0. So whenever our C value here is less than 0, we have no solution. And so there's nothing to solve, and we're done. Okay, no solution, and we move on. Okay, C. So we have our absolute value of AX plus B here, and then C, where would our C term be? Well, our C needs to be over here, but I have this -4. So before we analyze this, let's add 4 to both sides so we get our C value. And we see that our C value is greater than 0, so this means we are going to have two solutions. So we need to split up this absolute value to show 3x minus 5 could be equal to a positive 10, or the 3x minus 5 part inside the absolute value here could be a -10. Again, because a negative absolute value of a -10 would be a positive 10. So this -10 could work inside here. So let's add 5. 3x equals 15. I'm going to divide 3. X equals 5. Okay. Now I got to do this one. I'm going to add 5. -10 plus 5 is -5. -5/3. So let's check this just to prove it. So the absolute value of 3 times 5 minus 5, put an absolute value there, then minus 4 equals 6. So 3 times 5 is 15, minus 5 is 10, absolute value of 10 is 10, minus 4 is 6. Okay, that worked. And then I've got absolute value of 3 times -5 times 3 minus 5 minus 4 equals 6. Okay, I'm just substituting in the 5/3 here. So 3's cancel. -5 minus 5 is -10. So absolute value of -10 minus 4 equals 6. Absolute value of -10 is 10. Minus 4 equals 6. And that works. So these two solutions work. Okay, we look at this. C equals 0. So this means we have, I've been using red, one solution. Still think this brush is too thick. One solution. So I'm just going to remove the absolute value here and set it equal to 0. X. Subtract 10. -5x equals -10. X equals 2. So if I put this 2 back in here, I get absolute value of -5 times 2 plus 10. And I get -10 plus 10. Negative 10 plus 10 is 0. The absolute value of 0 is 0. That was supposed to be a check. Whoops. All right. So those first 4 examples are done. That's how we solve absolute value equations. Okay. So we've got 3 examples here of solving some other types of equations. This goes under other. Solving a 4th degree equation in quadratic form. Okay. So we have 3x to the 4th minus 2x to the 2nd minus 1. Notice that this exponent right here is half of the leading coefficients exponent. So our middle term exponent is 2, and our leading one is 4, and half of 4 is 2. So this is an important distinction or pattern to recognize, because we can rewrite x to the 4th and x to the 2nd using a quadratic form by making a substitution here. Let's say that y, we can use any variable. I'm going to use y. Let's say y equals x squared. I'm just going to set up this variable to be this, and then later on we'll resubstitute it. And now I'm going to write 3. Now instead of x to the 4th, I'm going to say y. So y was x to the 2nd, and it needs to be x to the 4th, so that means I have to square that. So y to the 2nd, I think I'll write it like that, minus 2. Now instead of x to the 2nd, we're going to make a substitution of y. So I have 2y, and then now I've got minus 1 equals 0. Okay, this is a quadratic, and it's already in standard form. So now we have many different strategies to solve a quadratic. We could factor, we could use quadratic formula, we can complete the square. Why don't we see if this is factorable, and then if it isn't, then we'll use quadratic formula. So the leading coefficient is 3. There's no GCF here, so how about we do we'll do a times c and find the factors that add to b. So 3 times negative 1 is negative 3, and we want to find the factors that add to negative 2. Okay, I hope you got this one. The factors are negative 3 and 1. Okay, negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So now we're going to rewrite our middle term here. Zoom in. Middle term here is going to be minus 3y plus 1y. Okay, there's my negative 3 and my 1 right there, minus 1. Right? Just broke up that middle term into those 2 terms. And now we're going to find the GCF of the first 2 and then the GCF of the second 2. We are factoring by grouping now. So GCF of the first 2 would be 3y. And we factor that, we left with y minus 1. And then the GCF for the second 2 here is just 1. So I'll just say plus 1. And that would leave me with y minus 1. Notice how the binomials here are both equal. So I can pull that binomial factor out of these 2 terms, and that would leave us with 3y plus 1 equals 0. And now we use the multiplicative property 0. We set each of these parts equal to 0. And then we're going to solve these linear equations separately. And I get y equals 1. And I get y equals negative 1/3. Okay, now don't stop. We're not done. So remember, y equals x squared. So now what we need to do is we need to take 1 here for y and put it in for this y. So we got 1 equals x squared. And we have this negative 1/3 here. We're going to put that in for y. Negative 1/3 equals x squared. Okay, now what we're going to do is we're going to solve for x. So how do we solve x? How do we undo the squaring? What's the inverse operation of squaring? Square root. So the square root of 1 is plus or minus 1. And then we're going to take the square root of negative 1/3. And we're taking the square root of a negative number here. So that means we have an imaginary. So remember that negative 1 is I. So if I say square root of negative 1 times the square root of 1/3, we're just going to break this up here so we can see this, right? That's negative 1 times square root of negative 1 times square root of 1/3 is the same as square root of negative 1/3. And now I'm going to replace this with I, and I'm just going to leave this as root 1/3. And it's plus or minus. Okay, so I ended up getting two real roots right here, two real solutions, plus or minus 1. And I end up getting one pair here of imaginary numbers that these aren't real solutions here. But as you see, we know that this was a degree 4 equation right here because of the leading exponent here is 4. So there's 4 possible solutions. And we got 4 solutions, but 2 were real and 2 of these were imaginary. So really only 2 real solutions. Okay, that's how we do those. This is simple substitution here to make it just a plain old quadratic. That was factorable. Let's use a similar idea here when we have a quadratic form containing a binomial. So here's the binomial, it's x plus 2, and we see it's x plus 2 quantity squared, and over here we have a binomial, just x plus 2. So if we were to set y equal to the binomial here, and then make a substitution, we would get y squared plus 11 times y minus 12 equals 0. And how about just rewrite that? So it'd be y squared plus 11y minus 12 equals 0. And now we have a quadratic. Kind of an easy one here too. With leading coefficients 1. We could factor this, right? So what are the factors of negative 12 that add to 11? One and 12, let's say a negative 1 and a positive 12 would add to 11. We have negative 2 and a 6, a negative 3 and a 4. Hope you see that the correct factors would be 12 and a negative 1, right? So how about we go x plus 12, or y rather, y plus 12 and y minus 1. And then we use the multiplicative property of 0, and we get negative 12 and 1. Well, you set these equal to 0 and solve. I hope you guys see it's just negative 12 and 1. Now that's what y equals. We need to solve for x here. So what we're going to do is we're going to take each of these y's and set it equal to x plus 2. So I've got negative 12 equals x plus 2. And then I also have 1 equals x plus 2. Guys, I've just substituted these values in here back into y. Okay? And now we're going to solve it. Zoom in a little bit. So we got x is negative 14, or, okay, so we got negative 14 and negative 1. And look, we got 2 solutions there. And we see that this is still a degree 2 equation, so we'd expect to get 2 possible solutions, and we did. We get two real solutions for this one. Okay? Number 11. Solving a rational equation. Rational meaning we have a fraction, a ratio, right? Leading to a quadratic. Okay. So let's take, I'm just going to rewrite this here. You got a lot of space on your paper for this one. So maybe let's rewrite it with a little bit of space between each of these terms. Okay, so back in section 2.2, I think it is, we were dealing with rational equations, and in order to, our first step in order to work with those equations was to get rid of these denominators by multiplying through by the common denominator. And so I hope you see here, so we got x minus 1 and we have x plus 1, and I hope you see right here, this is the difference of two perfect squares. So we can rewrite this term right here, this denominator, as x plus 1 times x minus 1. This is a conjugate pair. And notice these two factors are the same as these two denominators. So our common denominator here that we're going to multiply through by is x plus 1 times x minus 1. And that will cancel all of our denominators, and then we'll be able to work, how about I put this one over here, x plus 1 times x minus 1, and then even here, got to do it to every term. Okay, so x minus 1 cancels there, x plus 1 cancels there, and these both cancel over on this third term. So now, well, I've got x plus 1 times negative 4x. We got to distribute that. So we're going to get negative 4x squared minus 4x. Okay, I just distributed that into both of those terms in that binomial. And then over here, I've got 4 times x times and 4 times negative 1. So that gives me 4x minus 4. And then over here, everything canceled. So I'm just left with the negative 8. Right? Now I've got negative 4x squared. Ooh, these cancel. That's nice. Minus 4 equals negative 8. How about let's add 8 to both sides. So now we got negative 4x squared plus 4 equals 0. And so just an x squared term here. This I've got, so let's think about GCF here, greatest common factor. Let's take out a negative 4. And that leaves us with x squared minus 1. Okay, take a look at this now. We've got another conjugate pair. In fact, we just did this conjugate pair before. It's x plus 1 times x minus 1. So when we use the multiplicative property 0, we get x. So if I were to write this out again, so it's x plus 1, we're setting it equal to 0, and this one we have x minus 1, we're setting equal to 0, and then we solve, we get x is negative 1 and 1. And we think, oh, we're done. That's our solution. But wait, we have to be careful about excluded values. If I were to plug these back into the original equation, will it work? So if we see right here, this x minus 1, do both these solutions work? Let's see, if I put a 1 in here for x, we would have 1 minus 1 in the denominator, and that means I would be dividing by 0. So 1 does not work. X cannot be equal to 1. Now look at this -1. If I were to put this -1 in right here, this would give me a 0 in this denominator, and that does not work. So x can also not be -1. Over here in this one, I hope you see, it doesn't matter if it's -1 or 1. If we take -1 or 1 and we square it, it becomes +1. 1 minus 1 is 0. This would give us 0. So we have to exclude 1 and -1, but those are the only solutions that we are able to come up with. So what do? We write no solution, because the values that we came up with ended up being excluded values. And so there is no solution for this rational equation. And we're done. Okay? So it's always important to check our work when we're dealing with rational equations. When we have unknowns, we have variables in the denominator. Okay? And that's it. That's all the notes we have for this section. I hope that makes sense, guys, and I will check you later.